never ending. So it's straight and never ending. Meaning it goes on forever and ever and always and forever and ever. It keeps going on. And it goes on and on and on and on. Are you sure? You get it? Okay. And when we make a line, we're going to do that straight line. I'm going to use green for this first one. If you want to use green, you can, or just any color. I just like colorful notes. Okay, so we have that arrow, and then it goes across. I'm just going to use that line in my notebook to make that straight line. And then we get an arrow on both sides, so it goes never ending. All right, and when we name a line, we either have a letter at the end of it, or we just talked about with planes, we need 3 points. How many points do we need for a line? 2. We could have more than 2 points on that line if we wanted to. But I'm just going to put 2. I'm going to make point C and point W. Those can go anywhere on that line. Okay, and when we name that, we would name it line. So we put that little symbol, an actual line, above those points, C, W. All right, now in the real world, we talked about lines. Do we really have any good example of a never-ending line in the real world? That we can visualize going on and on forever and ever and ever and always? No. Maybe like the equator you can visualize, right? Like it goes around in a circle forever and ever and ever. Maybe. I don't know. It's kind of hard to talk about unless it's in that circle, but if it's nice and straight, it's hard to visualize. So instead of lines, we have a lot of line segments. So we have that word segment attached to it. If you think of that word segment, like you watched a segment of a movie, or you watched, I don't know, never mind. That's all I can think of with the segment. What does a segment mean? Half of it? Not quite exactly half, but yeah, it's part of it. So it's part of a line with endpoints. So we can decide where does it begin and where does it end. Okay, so I'm going to make a line here, or a line segment. So I'm going to have a point, draw that little bit of a line, and then a point on the other end. And let's call that P and S. So our name for that point we're still going to use that P and the S, but instead of putting a line with arrows above it, how can I show that this line doesn't go on forever and ever? We could add the points or just not include arrows. So we're going to do PS, and then we just put a line above that. Line segment, sorry, a line segment above that. I'm not very good at sometimes of talking about lines and line segments. So then we say this as segment PS. So a segment connecting P to S. Now, if we want to measure that, because today we're going to be talking about linear measure, what does it mean to measure something? Yeah, like the distance, the length, or the weight of it, or something. Some sort of measurement, you're taking an amount of it. So if I say P to S, if I'm going to label it, usually we label it in the middle. And if I want to label this, I'd label it 5. Let's say it's 5 feet. Now, really, that's not 5 feet apart. That would take up a lot more space than in our notebooks. But remember, we're thinking to scale. So when we label it on the picture, we put it between the points, and that indicates it's 5 feet from the endpoints that are surrounding that. Okay, to name the measure, we need a way of showing that I am talking about not this picture, I'm talking about how long it is. When we talk about that length, we say PS equals 5 feet. So when we're naming the segment, we're actually talking about that segment itself. We're talking about that segment PS. We put that line above it. When we talk about the measure, how long it is, we just say PS. We put them right next to each other. That means from point P to point S, it's 5 feet. You guys are doing great. We have 2 more vocabulary words today, and then just a couple examples, and then you get the rest of the time to work. Work, 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 work. No? Cool. All right. Next up, we have this weird word, weirdest word in the world, is betweenness of points. Exactly. Betweenness of points. If we talk about betweenness of points, what does that word between mean, or in between? Usually we see that word in front of it, in between.
You're in the middle of 2 points.
Yeah, you're in the middle. So if between me and Mr. Kwan, who's in between Mr. Kwan and I? Ansel is between Mr. Kwan and I. Who else is in between? Yorman. Smaya a little bit, just a little bit in between, not quite exact. More exact would be Yorman and Ansel, and Fatumo is a little bit in between, and then Smaya kind of gets a little bit out. But betweenness just means to be somewhere in the middle of the points. So if I draw a picture here again, we're going to draw that nice straight line. I'm going to just use a pencil to start off with. And I have some endpoints here. And I want a point between those 2 points. Somewhere on that segment, I need another point in between these 2 points. Does that mean it has to be directly in the middle of the points? No, just somewhere in the middle. I'm going to make it a little bit closer to the end than to the beginning, just to show that it doesn't have to be in the middle. Let's call this point K, M, and T. Now, as we talk about length and linear length here, what's important to think about, and this is something that you all know, you've done this before, you've done it in Google Maps before, you've done it on your way to another class before, you just haven't thought about it in a mathematical way before, is that we know that a part plus the other part will equal the whole thing. Okay, so for example here, if I have my part, what would be the first part of this segment? From what point to what point? K to M? Okay, so if I start at K, I walk to M, I pause there for a second, I chat with M, we hang out, it's a good time. But eventually I'm like, oh shoot, I'm going to be late for class. I'm going to add the other part here. What's my other part of that segment? M to T. So even though I paused in the middle at M, I walked from K to M, M to T. If I look at the whole length of what I walked, where did I actually start? K, I started at K, and I walked all the way to T. So if I add those lengths together, I should get that whole segment all the way. Okay, and that's going to be a really big part here that this lesson is about. So a lot of your homework today is going to be about thinking about, if I know the whole thing is 50 yards and I walked 30 yards from K to M, how many yards would be M to T if the whole thing is 50? I'm thinking if the whole thing's 50, this is 30. What do I have to add to 30 to make 50? 20. So it's 20. See? Math, the part of it, not too hard. Just making sure we know the vocab. All right, next up, we have congruent segments. Last word for today. Congruent segments is something that you are going to get so familiar with, and by the end, you're going to be like, I don't remember learning this, I just know it, because we use it so much. Okay, we use this every lesson, almost in every chapter for the rest of the year. We're going to use that word congruent. Okay, and what congruent segments means is that they are the same length. That they are equal. Great, so I'm going to draw a segment here. We'll call that FH. And then I'm going to draw another segment that's the same length. But just because it's the same length, does that mean it has to go start exactly in the same place and end in the same place? No. Does it mean it has to just be like the same but right below it? No. It could go up and down and be that same length. I want to try and make it about the same. We could call that NV. Okay, now, did we take out our rulers and measure exactly that those are exactly the same length? No, we kind of estimated about. So we need something in the math world that says to our reader, yeah, these might not be exactly the same length, but I meant them to be. Even though if you took out a ruler, I'm pretty sure this one's shorter than that one. Okay, but I want to show that these are the same. So the way to do that is by using tick marks. So we use this little tick mark in the middle, and we match that tick mark with something that goes with it. So if I see that this NV has a tick mark, I know that these two match. They belong with each other. They're the same. Okay. Now, if you have lots of different segments, instead of just using one tick mark, we could use 2 tick marks. And then we know whatever 2 matches with 2. But the 2 doesn't match the 1. Does that make sense?
Yeah.
Okay. Now, our symbol for this, we're going to start by naming the segment. We're going to say FH. And we're naming that segment with that line above it. And we say is congruent to. So when we say is congruent to, we're saying that they're equal. But in geometry, we're going to find out that it's more than just equal. We're saying that they are exactly the same. So we put this little squiggle above it. So it's an equal sign with a squiggle. So FH, segment FH, is congruent to segment NV. So I'm saying right now, when you look at these segments, even though they don't look exactly the same, they are exactly the same. I'm telling you that for a fact right now based on that statement. And what that tells me is that the length, F to H, when we do length, we don't do that line above, we just say FH. Whatever that length, FH, it's equal to the length NV. All right, we're going to just do one example today. So if you want to write like example 1 or just example, or if you want to do a little dashed line across saying that this now is a work problem. That was all vocabulary so far. Lots of vocab this chapter. Yikes. So if you want to do a little dashed line across saying we're done with vocab. If you want to write example, normally I just start with numbers, but it's kind of goofy to number 1 and then not have anything after number 1, right? Number 1. I don't know. All right. We're going to find, this is going to make sense as we go. We're going to write down the problem first. So this is all the problem. Find PQ. We know that QT is Miss Morrell. She's a cutie. No? is 3 millimeters. And PS is 18 millimeters. Okay, again, this is not the whole problem yet. I'm going to give you some time to write that down. Make sure you get that written down correctly. Find PQ. QT equals 3 millimeters, and PS equals 18 millimeters. There's also a picture with this problem, so before we even start solving this problem, we're going to draw the picture that's supposed to come with this problem. Okay, so we're going to draw a segment. So points on both ends. And then over here, we're going to draw a point a little over halfway. And then one more point kind of in the middle there. So you should have 4 points. If it's not exactly like this, that's okay. Because we're going to mark it up so that mathematically what we say works. Not always do our pictures in math match up with the actual math because we aren't using computers to generate this. We're not being exact. We're showing it quick. All right, here in our first point we have P. Our next point we have Q. Next point is T. And then we're going to end with S. Last thing about this picture that it tells us is it has this tick mark here and this tick mark here. All right, so far if you're like, what the heck, where did we get any of this? We didn't make this up. I made this up. I gave it to you. What you have to now do is, based on this information, find out what PQ is. All right, so labeling it is going to be helpful. So what are some things that we know? Let's start with that information. What do we know?
QT is the same distance as EMS.
Oh, good. How did you know that, Tyke? QT is the same as TS. They both have that tick mark, and that tick mark means that they are the same because they are equal because they are congruent. Good, congruent. So because they're congruent, we know they're the same. What other information am I given? What does the problem tell me? Good. QT is 3 millimeters. I like to color code mine, so you can go ahead and do that too if you want. So I'm going to put a 3 there, saying that that's 3 millimeters. What other information do I know? Good. PS is 18 millimeters, and P all the way to S. So because there's points in the middle there, to show P to S, we do that little bracket at the bottom. P all the way to S. Is 18. So I know that that's my whole amount. What am I trying to find? P to Q. So I'm going to put that PQ here, put a question mark. Or if you wanted to be super mathematical, what could you use instead of a question mark? If you wanted to be algebraic. An X. Cool, an X. If you wanted to, you could put an X there. All right, is there any other parts of this diagram that we can label before we start actually doing the math? You say yes, Tommy? No? You're just nodding your head? jam into your own music in your head. No, I'm just kidding. This has to do with something that Tyke said. He noticed that QT had that tick mark and TS had that tick mark. What did those tick marks mean again?
They're the same distance.
They're the same distance. So if QT, which is me, I'm a cutie, no, is 3, how much is TS? 3. So we can throw a 3 there as well. You got it. All right, so now what we know is we know that when I add all the parts together, all the parts are going to equal the whole, the 18. So I'm going to think question mark plus 3 plus 3 equals my whole thing, 18. And then we're going to just find out what is that question mark. So it's like we're solving that equation. What's 3 plus 3? 6. I'm thinking what plus 6 is 18? Whoa. You guys are so smart. Did you think of it as what plus 6 is 18 and you filled in that blank as 12?
No, I minus the 2 threes.
Good. You minus the 2 threes or minus the 6?
Minus the 6.
Yeah, either way. So one way to do that is you can actually think to yourself, what plus 6 is 18? If you don't know the answer, you could just plug it in your calculator, try a bunch of numbers. Or we could use subtraction and think 18 minus 6. So we do the whole minus the part. If you need to write that, you can. If you don't need to write this part, if you're like, yeah, I did it, I got the answer, don't write that part. It's your choice. What's 18 minus 6? 12. So our last part now is to appropriately label our answer. What is 12? From P to Q is 12. 12 what? Oh my gosh. 12 millimeters. And that would be our answer. I have a habit of boxing my answers. Those of you that had me last year, you know that. When I was in 6th grade, Miss Penny was my 6th grade math teacher. If we didn't box our answers, we got the problem wrong, even if you had it right. So I just always box my answers. I'm not saying that in this class. You do not have to box your answers. I'm just saying I have a habit of boxing my answers because I learned in 6th grade if I didn't box them, I got it wrong, which was very annoying. All right. So